So now we want to talk about the types of reactions, and this is going to be a relatively short section, 5.4, because there are only 5 types of reactions that we need to be familiar with. And let me get this going here so I can. Okay. So there are 5 types of reactions that you need to be familiar with. And the first one is called the combination reaction, and you will not hear me refer to it as a combination reaction. I will always refer to it as a synthesis reaction. So that's what you need to look for. Decomposition is the second, single replacement third, double replacement, and combustion. Now there is a subset of double replacement reactions called acid-base reactions, because we are not getting away from our acids and bases quite yet. So again, the very first one that we're going to talk about is the combination reaction, and of course, again, for me, this is going to be called a synthesis reaction. And synthesis is basically the act of making something. So when determining whether a chemical equation is a synthesis reaction, you need to locate your yield sign. And from previous videos, you know that your yield sign is the arrow. The yield sign is going to be an indicator of what type of reaction this is, as in a synthesis reaction, you only have one thing to the right of the arrow. So when you're making something, you have all this other stuff on the left side, and it comes together to make one thing on the right side. Now, I want you to know that in addition to being able to look at the chemical equation, you should also be able to look at the word format of it, because I can easily say magnesium reacts with oxygen to yield magnesium oxide, and you should be able to tell me what magnesium oxide looks like, because we know magnesium has a +2 charge, oxygen has a -2 charge, so they just come together to form MgO. Now this equation is already balanced, so that's why you have a 2 in front of your magnesium as well as a 2 in front of your magnesium oxide on this side. Also note that because oxygen is diatomic, that is why you have to write it as O2, because when it is by itself, it must have 2 atoms. The second one that we need to discuss is the decomposition reaction, and it is the direct opposite of the synthesis reaction. So if the synthesis reaction has one compound on the right side of the yield sign, you can expect that the decomposition would have one compound on the left side of the yield sign, because we are taking one thing and decomposing it or breaking it down into multiple either compounds, as you see here, or simply elements. Again, even in a decomposition reaction, this is mercury to oxide. I have that 2 there because mercury is a transition metal. So again, you would need to be able to show me what mercury oxide looks like, and then when it breaks down, it's going to break down into its individual things, which would be mercury and oxygen. The last one I want to talk about for this particular video is single replacement. In single replacement, you have one thing that is single by itself. For example, here we have zinc that is by itself. This automatically symbolizes to you that this could potentially be a single replacement reaction. What you also need to look at is on the right side of the yield sign. Is there also something else that is by itself? Absolutely, we have hydrogen. So what happens in a single replacement reaction is that this thing replaces this thing. So therefore, when you look on the opposite side of the yield sign, you now see zinc with chlorine instead of hydrogen. And now hydrogen is by itself.